Hello guys. Today I'm going to make a video about my own decision tree overlay. So it's a very specific IP that I built for users to use on PYNQ framework. So this is a pretty old repository. So if you go to my repository, you probably see the latest commit was July last year. So let me first check if um, this is the pink Z1 board. I just booted up. It was um, unstable image, so it gives me error. But I also have a local fork of my repo. So let me first check. I think um, it might need some updates. Yeah, so let's just get the update there and check whether this is the latest one. Yes, it is now. So let me first try to rebuild the IP, and while the Vivado is building the IP, I can explain what it does and what I did for the for the RTL code to work with the Vivado project. Right. So all right, let's get to the project. PYNQ decision tree. Go to over. Maybe there's a makefile there for me to use. If not, I perhaps need to build it by myself again. Okay, so if I go to this IP repo, um, there's the decision binary tree IP. So if I look at the boards IP, and there's only one folder called binary tree. Um, I don't know which version of Vivado I was using, but now I'm thinking about using 18.3 to rebuild this IP. So let's go to the PYNQ decision tree 3 stages, because the tree only has 3 levels. While users can change the number of levels to more, but I'm just using 3 as a simple example. I'm going to perhaps run this makefile to build the decision tree overlay. But perhaps this Tico, I need to make some modification. First of all, I think it's using 18.2. Let me see if I have the version somewhere. Um, yeah, this one, those IPs may need to be upgraded. Um, it doesn't see it doesn't say anything about the Vivado version, so perhaps I'm going to use 18.3 directly to build this. If not successful, I'm going to fall back to use other version of Vivado, but hopefully it should be fine. So go to boards, PYNQ Z1, decision tree 3 stages. Uh, which Vivado am I using? 18.3 is fine. So okay, so there's a constraint files there. So if I go to, let me see, decision tree 3 stages, board slash PYNQ Z1, decision tree 3 stages, go to Vivado. Then I see this wrapper.v. Um, Perhaps I need to make sure that I don't have a wrapper code. I need Vivado to generate this wrapper code by itself. Okay, I see it's 17.4. It was pretty old. I need to upgrade this. So maybe let me fall back to use, wow, this PYNQ Z1 image is very unstable right now. As I'm debugging using 18.3 version, the UART is giving me errors. So let me use 17.4 first, and then try to upgrade everything from uh, the, the Vivado project. So which Vivado? I'm going to source 17.4 released. I need a released version. Installs. For generally, well, for most of the users using Linux system, they will have to do similar things as I'm doing right now. So you just need to source corresponding Vivado version. So now I have 17.4. So let me make this. Um, Hopefully it will succeed, and then we can start from there. This is not a big project, so you shouldn't take too much time to complete. Actually, I should first find out whether I'm building the bitstream or not, because I really don't need to build the bitstream. I only need the block design, and then I can upgrade my block design from there. So let's first get rid of this. Let me find the corresponding location I'm running it. PYNQ Python decision tree. Boards ping z1 decision tree 3 stages. Then this one, I'm going to change this anyway, so I will not make any backup here. I think it's going to the end. Yes, so I just need to get rid of this. I don't need the, well, I'm going to refactor this one a little bit, so I have a separate Tcl file to build the bitstream. This bitstream decision tree 3 stages, I only needed to build the block design, nothing else. So perhaps I need to get rid of this as well. So to generate the wrapper, I don't have to write a separate .v file. What you can do is you can do something similar to the what PYNQ is doing. So if you go to PYNQ repository, this is PYNQ repository. Go to boards, PYNQ Z1. Let's just choose one example. I think it's base article. Well, I think um, eventually this one has to be refactored as well. But now I'm just borrowing the last piece of code where the wrapper code is generated. So I think it's here. Add top wrapper and an XDC file. You can do similar things for your block design. So if you generate the wrapper for you, you don't have to include that. Um, well, let's first, because I don't know the block design yet. So let me first build the block design, and then I can make sure that every interface is there. I can, okay, like a make. All right, I will wait for it to complete. Okay, seems like the block design has been built. So what I'm going to do is I'm going to open it. So if go to decision tree 3 stages project, there's an XPR file, which I can open directly in Vivado. So let's see. Well, I didn't mention what it does. Decision tree is like a machine learning algorithm where you can, you set up a number of fields, and then you have each different criteria in the fields, right? And then based on the input value you gave, you kind of search the tree for the corresponding the final decision, right? So um, there are some notebooks that I gave about the examples. Let me, it's very easy to visualize. Go to notebooks, decision tree. So this is like an example of C4.5 decision tree. Um, there are more information there, and there's some references that you can check. So this is like an imaginary decision tree. So we have so in this case we have 3 levels, but perhaps in real world you need like more levels. So in this decision tree we are making um, some decisions between you know um, for different uh, weekend plans, right? So if the weather is sunny, I go to left. If weather is not sunny, it's not good. I go to the right side. So there are the two branches. So if the weather is sunny and the condition is windy, I mean you get some pretty strong wind. And if the day is weekday, you go to work, right? So if no matter if it's sunny and windy and the day is weekday, you go to work. So it's similar for other decisions as well. So you can see, there are different fields like the weather, like the condition, I mean the air condition, or like the whether it's a weekday or your age. This is just an imaginary one, so perhaps it's not a very good example, but you can get the idea. So based on different fields, you have like weather, condition, age, day, those are fields. And based on the values, like sunny, windy in each field, you go to different branches. And then finally, you make decisions like whether you work or you stay at home, or, do you do shopping or do you just play video games, something like that. So this is like a C4.5 decision tree. It's like a binary tree. It doesn't have to be balanced. So you can have like a very long left branch, but a short right branch. But now, this is just like an example here, a very special example. Okay, the Vivado project has been opened. Let's get into it. Am I recording? Yes. Um, let's open it to see whether we really need the wrapper, because, well, if not, we can just have the Vivado to generate the wrapper code, and then I can simply delete that wrapper.v file in my repository. I think I don't see any dangling inputs or outputs. So this is like also the block design. I also want to show you the block design. So if I do this, so you see this is like a very standard way to connect your XC IP. So uh, this is my IP. It's called binary tree, and it takes input from a slave XC interface and outputs the results in master XC stream, right? XCS, that's XC stream. This is also XC stream for the input. I mean for the input values, but you also have some XC interface, not XC stream interface to control the decision tree, when it has to reset, when it has to load all the values in each node, right? So that if you have a look at this, so the PS is giving values in you know, giving value to the XCDMA. The XCDMA is driving this. So it has two channels. One is from memory map to stream. This is a master XC stream, memory map to stream. So you get the input values from the DMA, you know, directly feeding it into the binary tree, and then the binary tree process it and get the results back, and it outputs the value in a pipeline fashion, and then gives the value back to the slave axis stream to memory mapped, because on the processor side it has to be memory mapped, but on the pipeline side, I mean, the binary tree is internally a pipeline. So on pipeline side, you only need to feed in data in a streamed fashion, so you get very high performance, very high throughput. Seems like we don't need to do anything. So let me close this. and I will just um, so what I'm going to do is I'm going to upgrade this to 18.4. This is a very tricky thing because most people don't know how to upgrade their Vivado version. So remember that I built the block design in 17.4, but now I want to use 18.3. So I just source projects as, just for Linux system, I need to get the correct source settings. Vivado 18.3 settings S CSH. So now if I check Vivado, I know it's 18.3, so I can use Vivado to directly open this. And then perhaps the Vivado is going to warn me that some of the IPs need upgrade. But that is fine because Vivado is usually doing that automatically. Um, so I just need to, you know, ask Vivado to do it. I won't be able to track all the IP status. Well, there are not too many IPs in my design, so it won't take a lot of time. Um, let's see. Okay, open it in 18.3. Okay, so you need to automatically uh, ask Vivado to automatically upgrade. And then based on the new block design, I will get the TICO file and I will change the TICO file. Basically, I will replace the contents in the old TICO file. Report IP status, it gives things like something has to upgrade, and then I just click upgrade selected. Okay, let it upgrade. So at the same time, if I check this one, this is the original TICO file. Well, not the original because I deleted the bitstream part, generation part. So okay, it's 17.4. First, if you check this TICO file, you see that it's 17.4. I will change it to 18.3, and then there are multiple places that I want to change as well. But now let's go back to Vivado. Says IP has been upgraded. I want to skip the outputs generation because I don't want to generate anything. I want to, let me first, seems like IP has been upgraded. I need to first validate design. Well, if you don't validate design and you directly write bdtcl, call the tcl command write bdtcl, it will warn you that you have to validate your design. So, um, yeah. Yeah, those are fine. Those are like the DDR, um, parameters. Well, we got that parameters from somewhere, so it shouldn't really matter because we are using negative number. Actually, they won't have any effect on your system. So this is fine. We got only like, well, ideally we shouldn't be getting any warnings, but this is fine because we have tested this. We know what this is about, you know. So let me write bdtcl. I'm going to just call it bdtcl, new.tcl, because I know where it is written. Well, usually you can see it has been written in this place, but I know where I'm writing it. So decision tree 3 stages, that's the project folder. If you go inside it, new.tcl is there. So if I open new tcl, and what I need to replace is the I think it's from the check IP from here. So I'm going to copy all the way down and replace it. Place it. By replacing it, I need to find the corresponding location of check IP. Okay, now it has been upgraded to 18.3 version. The Tico file has been upgraded to that, but I need to make a few changes. So 18.3, first of all, script Vivado version has been upgraded to 18.3. And then I want to, there's the reason why I want to upgrade, replace the part after check IPs is because I have some additional changes here, especially set IP repo path, this call. I need it to be there, but the new .tico doesn't have it, so I don't want to override my old changes. So if I look at the what PYNQ is doing. PYNQ also has this. Let me double check whether the repo is correct. Yeah, seems like what I want to do is I want to set an overlay name and then I will stop calling it. The overlay name and design name are both called base or both called decision tree in my case. Is it decision tree? Decision tree is 3 stages. So in that case, I will have better namings. So I need to copy set overlay name here. And then here should be overlay name followed by overlay name, something like this. It's easier for me to change the overlay name at a single place instead of multiple places because I think where am I getting the other decision? Set a regional directory. Remote BD flow. Do I have that? Anyway, I don't know what this is about. Let's see. Three stages. This is fine. This is fine. Design name. Set a regional directory. This script was generated. I'm confused here. This script is generated. I don't need that. Actually, I just need to copy something like this. If you do not read it, okay. After change design name here, I just copy this thing there. So it's commonly used. I don't want to reinvent the wheel or make very funny difference between something. Okay, change design name here all the way to this. This should be fine now. Overlay name, design name. All right, go to the end. I don't need to. Yeah, this is fine. I'm going to close this. I need to make additional tickle file because I changed the decision tree 3 stages.tickle, but I still need something to be able to build the bitstream. So let's borrow something similar from PYNQ. Usually this flow is recommended for user to use. Let me see, I need to get the tickle refactor one because the tickle refactor branch is doing something better because it separates the building of the block design and the building of the bitstream into 2 tickle files. I want that. So I want to be able to, just call one target to just build the block design without running the implementation. So the make file, I'm going to try something similar. Well, it's called decision tree 3 stages. I'm not going to retype it. Overlay name, block design name, HLS IP. We are not building HLS IP, so I can delete this target. block design is fine. We have that. Build bitstream, we need to prepare build bitstream.tcl. Check timing, I need to copy similar thing from the PYNQ and DSA, which generates a HWH file. Is well, I need to um, for that one, I need to check the block design to make sure that it works. So let's first not do the let's do it one by one. Block design, we have it. So bitstream, I'm going to copy that. So let's just get another TCL file. Build bitstream.tcl. Let me borrow one build bitstream from build bitstream tcl. Decision tree is three stages. Looks fine. So it opens the block design at top wrapper and XDC file. Hopefully we don't have any, we only have the .v file. Actually, we don't need any XDC file. So I'm going to delete this Vivado folder. We're not using any IO, so there's no actual constraints on this overlay. Get rid of the Vivado folder, and then need make wrapper, we still need it. Add files, we have this set property wrapper is fine, import files. I don't need this line. And update compiler. Perhaps this one we still need to have it, but this one import files. We don't need it. Then running implementation. Okay, now this looks fine. Bitstream we have it. Now check timing code. Where am I? Check timing.tcl. See. So check timing is making sure that the block design or the bitstream you build doesn't have any timing violations. It's like going to the timing report and check the negative slack. So I have that build a check based article. To borrow the same TCL file. So basically for user to design their own thing, they will have to do very similar flow. Oops. Decision trees, three stages. Copy here, copy here. So it opens the time summary report and then check the timing. So if it's successful, it will just tell you the timing constraints are met. So now we have block design upgraded for 18.3. We have bitstream, which builds bitstream, and we also have the check timing TCL. The last thing that we are going to work on is this DSA. So the reason why I need it, I need to check the block design is I want to make sure that the port or the F clocks enabled correspondingly. So right now, if you check the design, there's only one clock enabled, F clock 0, I think. So perhaps for the DSA, it's going to be a very simple one. GP, HP port, we are only using HP 0, so all other HP ports are available. Yeah, so keep on. So go to clock configuration, I guess. Yeah, only clock 0 is enabled. So, and the clock reset module is called processor system reset 0. We're going to need that. So why do we need this build DSA? Because when we construct the project, we also sometimes we also want to construct a SDX platform for this. So build DSA is a natural way. The Tico file is a natural way to give you that path. So it's easier for you to decide whether to use SDX or not. So go to my student tree. What is called? Let's see. Also going to borrow it from PYNQ. Build base DSA.tcl. This file needs some modification. I will show how am I going to do it. So go to decision tree, check timing. It should be build decision tree 3 stages DSA. Okay, it might be a bad name, but the naming convention seems like to be build underscore overlay underscore DSA. So we have a long overlay name, so there's no way that we can change it. Decision tree, 3 stages. Open project and block design. Set SDX platform properties. This is fine. So now you see platform clock. We only have one clock, so I'm going to remove clock 1, clock 3. Now I only have one, and then XC port. Well, first of all, process system reset has to be the same name to be consistent with the name it showed in the Vivado project. Is processor system reset underscore 0. Let me check whether I have it. Yeah. ACP, I don't need to use it, but I can get there. HP1, HP3, and I think also HP2 is available. So I'm going to put it there. That means the SDX platform can use it, but I don't really have it in our design, right? So remember, we only have HP0 used in our block design. If you double check, yeah, only HP0 is used. All right, this is fine. We're using one system interrupt, right? Let's see. Actually, this block design needs some modification. To be able to use the system interrupt. Let's just add that thing. I need to enable. I don't remember where I can enable it. Interrupts, maybe. PL to PS. This one, I think it's this one. Yes, RQF2P, and then I'm going to add a concatenation block. So that's a very standard way to have a valid top module is currently invalid in the you like to automatically new modules. I don't care actually. Number of ports, let's just do one. It's fine. And validate the design first. This is connecting like an empty concatenation block to IRQF2P. I'm going to write the new BDTCL. I don't need to. So I will explain what I doing here? So someone may get lost. So I'm adding this new one. So that means my block design has changed for the going to this new two.tickle. Going to copy all the way down and replace the old block design. Where is decision tree 3 stages.tickle. I think from the check IP is where I started to. All right, let's check whether I have the concatenation block. Yeah, it's there. I'm using it. It's fine. Some people may wonder, I don't have any input to the concatenation block. This is perfectly fine because, the SDX platform will read this and it will start connecting, adding more interrupts to this RQF2P. There are like 16 interrupted pins that you can connect. Right now I'm using one, so the SDX in SDX platform you are only exposing the left 15, right? So there are in total 16, and you are using one of them. So that in the SDX platform specification, you need to set it to from I equals 1 and I less than 16, you add interrupt variables, something like that. So you can't start from I equals 0 because you are connecting the pin 0 there. So hopefully this is fine. Everything looks good. Um, good. Make clean doing this right thing? Yes. Okay. I think I've upgraded everything, so it's okay to delete this project entirely. So I don't need to save because I'm deleting the Vivado project anyway. Um, but doing that, I can just run make clean. So everything is cleaned. One thing is that I want the permission to be the same. So I'm going to change mode 644, build bitstream, build decision tree, and the check timing. Yeah, this is not necessary, but I really want to do it. Um, okay, I have all the TICO files. There are four TICO files. My make file is calling all of them, right? Check block design, one, build bitstream, two, check timing, three, build DSA, where is build DSA, four, right? Yeah, everything. Now I can just sit back and let it to finish. Hello, seems like it runs into a problem. I know what this problem is about. So it's finished all the bitstream generation, but finally it comes up to the place where I call check decision tree 3 stages dot tickle. I think there's a difference between the names. So if I check in the PYNQ repository, they are called check base dot tickle. So in my new one, I just called it check timing.tickle. That was a mistake. So I need to uh, copy this thing. Check decision tree 3 stages. Oh my God, that's a bad name. Okay. I don't want to run this thing again because the bitstream has been upgraded already. Has been generated already. Why should I uh, run the entire project again? I only have to make check timing. I think the project is it is called that thing, right? So let's see. The target name is check timing. Okay, after check timing, I also need to build the DSA. So let's do. So block design has finished. Bitstream building has been finished. So only have to check timing and DSA. check timing and DSA. So whenever, all those scripts have been finished successfully, I would probably clean the project and start from the very beginning to make sure, I don't do anything stupid. So seems like timing constraints are met. So if you check the outputs, you see timing constraints are met, and now I'm building the DSA. Um, so fingers crossed, the DSA tickle will not barf. So we will have the final bit stream. Oh my god, there's something wrong. Mm, no cells matched PS7 underscore zero. So I think it might be called the PS7 block design. I mean, PS7 block has a different name. So let's check. I don't have to reopen the block design to check. I know where it is. That's a very long block. Okay, so now it is called processing system 7 underscore 0. I can either change this, or I can change this to PS underscore 7, or I can change my DSA. So to make it um, to make it easier, I will just change this to processing system 7. Where is it? Let me see here. Get BD cells. There are two places where I made the mistake. So it should be called processing system 7 underscore 0. In that way, your Tickle file is able to get that information. So I don't have to make check timing. So only have to do make DSA. Let's check again. Hopefully this will work. So, when users are doing their own overlay design, they may run into very similar questions or problems as well. So, but I think the pink is a very good example showing you how to do this flow by yourself. So it's easier to scale from, one single design to multiple designs. So, okay, there's still problem. Let's see. Um, not the least significant available port expected in 0. Okay, so um, pardon me for that. So I think what I need to do is I need to you kind of because the concatenation block there is perhaps uh, an empty concatenation block, so it's not using any um, interrupt ping, right? So if you remember the concatenation block in the front of it, there's no actual output driving it. So the actual interrupt ping that you can start from is index 0. It's not index 1. So I made a mistake there again. So let me check. Build DSA, build DSA. Where's the build DSA? Here. So just need to set I from 0 and all the way to 15. So this is the place where I change. Hopefully this time it will work. Let's see. I think that's the only error we've seen here. And if this time it succeeds, I will make clean this project and then start from the very beginning. It's going to take another half an hour to build it. Um, let's see. When did I start this? Started building the design. Let's see. In 18.3, there are some problem with the tools, and I think we are getting this kind of a warning, like IO pad warning. I don't know how to solve this problem because the same Pico file never generated the warning in 18.3 or 18.2 or earlier version. So if any of those guys, any of you knows how to do it, I'm all ears, right? So I don't know how to get rid of those warning. I don't know where it's getting generated. See, okay, okay. Now it seems like everything is fine this time. So everything is happy. So I'm going to, because you see a lot of Vivado log files and then those nonsense there. I'm going to make clean this product, and you can double check that the you know, you only have the files you need, some TICO files, and you know those bit DSH, DFH, WH file will get replaced during the make flow, so I can leave it there because they will get replaced anyway. Um, so actually I only need the 4 TICO files along with the make file. So yeah, seems like the flow will be um, okay. I will just run make and let's wait until it finishes. Um, now this time, hello, um, I'm back. So I got a message that decision tree 3 stage has been built successfully. So if I go to the folder, I will probably see the new bit, new HWH, HDF, DSA files, those 4 files. I need to copy HWH bit and tickle onto the board to be able to run it. Um, so, um, but I think what I'm going to do is I'm going to commit the let me check git status. So I need to git add decision tree 3 stages dot tickle is git add makefile and then git remove vivado, and what am I adding? Build bitstream.tcl is something I need to add to the GitHub repo. Build decision tree 3 stage DSA. Check decision tree 3 stages. That's the timing check. Decision tree stages. Uh, decision tree 3 stage dot bit. DSA is tool is like a product. I don't want to add that. DSA and HDF files, like zipped files, I don't want to add them back. Only need to add the bitstream, and then decision tree 3 stages dot hwh. I think that's it. Let me check. So DSA, I don't need to include that. HDF, I want to ignore that. That's the decision tree 3 stages folder. That's the project folder. I don't want to add it. And some of the Vivado log file, which I don't want to add. So I will commit this as update to 18.3 and then commit the changes. All right, and there's one thing that I want to change is the instructions to install this. So after I check the repo, I noticed that in the README for 2.3 and 2.4, PYNQ 2.3 or PYNQ 2.4, I only have to do sudo pip3 install. Don't need to get the pip 3.6 install. Currently it's exporting the latest image v2.1, so I'm going to say it's supporting the latest image. Well, it's supporting pink. I don't want, maybe I can just delete this because I don't know whether I want to keep saying that for each release. So let's just remove that and assume that it's updated to the latest version. So I'm going to see. So after this, I should be able to see, refresh this page. Yeah. I'm going to use this instruction to install it. So hopefully setup.py doesn't have to change. Let me see. Setup. I don't know whether it's going to work or not. Um, yeah. Well, this notebook only um, copies the notebook. Notebooks hopefully it doesn't need to change. Let me first try to do it. Install this on board. So let's go to this and copy this thing. Password is Xilinx. Yeah, it's not taking a lot of time. Well, by the way, setup.py has to upgrade this to 2.4 or something. I can change that later. But let's first verify the function is getting correctly upgraded. Decision tree. So after installation, you see a decision tree in your Jupyter Notebook folder, and you go see 4.5 decision tree notebook. Let's run this together. So there are some instructions for you to read. I won't go through this, but basically it says you have some fields and you have some index to code those fields. So basically represent the code represents the values or the fields in binary values. And then based on the input thing, um, you can get different decisions. A decision is also represented by binary digits, right? So since you have 8 decisions, you have eight 3 bits to represent them. Um, so let's run this together. So first one is we got the mapping, and then let's taking a software approach. So this is like a software version of the decision tree. Um, yeah, let's ignore this because the ping still needs some patching. We are still working on that. So let's just ignore this for now. But eventually we will get rid of those weird thing. Populate the decision tree. Remember that's a software decision tree. And then if I have some example data saying that weather is not sunny, condition is rainy, um, and it's not a weekday, and your age is less than 50 years old, then you have your decision movie. Basically means you go to movie. So let's measure the performance of this. If I do this, like this is running it 10,000 times, so it will give you some data there. Okay, so to load those data into the software structure, it requires 2 seconds, and processing time for those, to make decisions is about 5 seconds. Basically, you're processing 2,000 packets per second, so 2,000 decisions per second. Okay, now I'm showing like a structure. Okay, this image may need to be upgraded, to be updated. I will do that, and then I'll do that later. And then it basically says now it's hardware decision tree. You build a bitstream as we just did. Load the decision tree overlay. So now is error. There's an error because it's no longer this path. I think in image v2.4 it starts from a different path. I think it's slash user. I don't know. Slash user slash bin. No, slash user slash local lib. Yeah, yeah. This is the place. um, what is called decision tree? What is the package called? PYNQ decision tree. So it's yeah, it's this path, right? So if you can see, let's see if overlay got copied over correctly. Otherwise, we have to fix this. Oops, cd PYNQ decision tree. Well, oh, by the way, seems like I need to upgrade that thing as well because it's not copying it um, from the correct location. So we build the image here, but I need to copy the bit HWH and TICO file to the place where I'm installing it. Right, so I need to copy it here, copy and replace, copy and replace. Okay, at the same time, I'm going to make other changes like set up the pi. I don't want it to be 2.1, 2 point, maybe call it 2.4 to be compatible with the next PYNQ release 2.4. And then this should be fine. And then in the notebooks, I want to, this is a raw, I want to /opt. Yeah, this path, I want it to be this path. Hold on a second. PYNQ decision tree. Okay, looks fine. I'll just modify. This is a very dangerous thing because I'm kind of modifying the raw code instead of modifying it in notebook. But this should be fine because I'm just only changing the path. User local lib Python 3.6 distribution package PYNQ decision tree overlays, right? Oh, overlays decision tree 3 stages, 3 stages stop bit. This should be fine. Now go to here. There are some things we have changed. So first, add setup of pi and the PYNQ decision tree overlays. Let's call it maybe also upgrade this. Yeah, other stuff I don't want to change. I want to add git commit. 2.4 release. Now let's not say that upgrade to compatible with 2.4. Let's just let's reinstall the package. Now it should have something new there. First of all, setup of pi, we have different version number than in PYNQ decision tree. Overlays have been upgraded. like the bit, HWH, and tickle file is there. And then perhaps I need to modify the setup to polish this. I need to change the setup.py a little bit so it directly gets the overlay from the boards folder instead of the place a pink decision tree here. But that's a future thing to do. Right now, I think everything's fine. Let's check notebooks. Should be fine. Check whether the path should be correct. All right, so let's check. Okay, it has been done. Go to decision tree. Is this app updated? Yes. Okay, now let's run this together. Together software approach. Well, let's restart. Still same thing. Go to movie, measure performance, 2 seconds to prepare data and 5 seconds to process data last time. So this time it should be something similar. 2000 decisions per second. Now load the overlay. It's another problem. I think there is a problem with my block design. This is saying that the interrupt parsing has something wrong there. The controller, because it's an empty one. Let's check the PL.py. Maybe there's a simple fix for me. It's very stable, well, unstable status right now. Where is it? Actually, I don't need the interrupt at all. I'm not using interrupt, so perhaps I can just get rid of this. So let's check the overlay class, what it has. Self.binary tree. Oops. Well, I hate this every time. Looks fine. Why am I getting this error then? Oh, maybe, let's see, maybe the overlay code has something wrong there. Not here. Another thing is we may want to, let's move the decision tree.hwh file to backup. In this case, we may have a just use the TCL file for parsing. Okay, that one is successful. So I then use this, looks fine. Then I configure the pipeline, which means I load the tree data. And then I search using the hardware decision tree, it gives me the movie. Decision is consistent with the software version. Let's run this. Now you see the time to prepare for 10,000 data is around the same time, 2.8 seconds, but the processing time is much faster, right? So it's like 2 milliseconds. So you can basically make 4 million packets per second. So if I check the performance, compare the performance and draw it in the graph, um, I will probably see something. The first time I'm running this is building the font cache, so it's going to take longer time. But the next time you run it, it should be pretty fast because it's just drawing data, right? So it shouldn't take too much time. Um, okay, now here you go. You see the, let's rerun this. Yeah, so to get rid of the warning, so you can see that the execution time is, the total time for software is this big. It's about 8 seconds, but for hardware, it's around 3 seconds. While the processing time, basically, you don't even see them, right? You don't even see it in this graph because it's so fast in hardware. Another thing to mention is that it's only a 3-stage pipeline. And well, it's a small tree, so it's pretty fast. Everything happens on the on Fabric, so there's no external communication for too much. There's no much external communication, so that's the reason why you get the throughput. So speed up is around 2,000, but now one thing is this is considering both the total execution time. So if you only compare the processing time, it's going to be much faster, right? So in another video, probably in the I will guide you guys on how to make the make an RTL IP accessible by by the X interface. So basically, I will use decision tree as an example on how I put our RTL code into a meaningful project, right? So a lot of hardware engineers know how to program RTL code, but they don't know how to integrate this along with the software piece, right? So PYNQ is a perfect platform for that. There's no doubt about it. So I will get that. And I will perhaps also fix a few issues. One is the HWH parsing. The reason why it now works is because I removed the HWH file, and the overlay is trying to use TCO file to parse the useful information instead. So by default, I always look at HWH file first. If it is not present, it will just look at the TCO file. So perhaps there's some problem with the HWH parsing. That was the reason why I commented it out, and then it works. So have a look at this example online. I hope you can try it by yourself, and leave me any comment or send me a message if you uh, feel interested about this. All right, thank you. I'm going to, have a little break after this. Thank you, everyone. Thank you, everyone, and have a good time. Bye.